All right, Miss Teasley here. Today we're in section 2.5 and 2.6, transformations and combinations of functions. So this first section that you have in your notes is pretty much already worked out. I'm just going to kind of go through and explain what we have here. So these are your special types of functions. You have f of x equals x squared, which is the square root function. F of x equals x cubed, which is the cube root function, and they have the shape of it. Then you have a square root function. F of x equals the square root of x. And then you have cube root function, which you're probably not going to see in this class, but we've ran into the absolute value function, all right, before. So this is the absolute function, value function. This is a v-shaped function. So all these functions that you have listed here, these are called parent functions. All right, parent functions are these particular functions in its simplest form. It's always going to go through the origin. So if you notice, all those start or have a point at the origin. I'm just darkening all those origin points. Right. So these are called the parent functions. So when we start doing any graphing, we're going to always start off with these parent functions. All right. So let's look at the first example that they have listed here. So let me scroll down to the actual examples. These are what we call transformations of functions. We're only going to deal with the first four. These are called translations. This is when you move the graph left, right, up, and down. All right, so I'm going to take the parent function and I'm going to move it in these different directions. So let's talk about what this f of x plus c and f of x minus c and then the f of x plus c in parentheses. Let's talk about what all this means. All right, so for example, if I tell you, so these are some little side examples before we start looking at the graph. If I tell you, for example, the parent function is f of x equals x to the third. And then I tell you that the new function that we're going to create is going to be f of x plus 2 behind it. So remember, f of x is just x to the third. So if you see it, they might write it with f of x plus 2, or they might write it as x cubed plus 2. What this means is anytime you have a function and there's a number at the end, that's going to be your up-down movement. Because that's a plus 2, it's going to move up 2 units. If I said that the new function g of x was f of x minus 2 in parentheses, or let's make it plus 2. Plus 2 inside the parentheses. Anytime the number's inside a parentheses, regardless of what the function is, that's going to be your left-right movement. Another way to write this without function notation, since we're talking about x to the third power, would be x plus 2, because that's what's in parentheses, raised to the third power. In this case, this is going to move 2 units left. All right, you would think a plus would move to the right, but it's the opposite. So this would be a nice little chart to have in front of you. So notice when it says x plus c, this is a horizontal shift left c units. So I'm going to show you this in Desmos. Desmos is really good because you can use function notation and you can see what happens using function notation. So let me open up my Desmos. Here we go. So let's see. So I start off with f of x. So I will actually type f of x. F parentheses x and equals x to the third power. So x, choose the button that has a to the b power so you can get an exponent to the third. So that's how a cubic function looks. That's your parent function. And then next, what I had was I took this f of x and I added a 2 to it. So I'm going to write this as f parentheses x and then put a plus 2 behind it. So notice how the green graph shifted up 2 units, and now you have that purple graph. So that's exactly what happens. So that point that was at the origin moved up to this point here, 0, 2. So I can write it as f of x plus 2, or instead of me writing f of x, I can actually write just x to the third. So x to the third plus 2. All right, so both will give me the same thing. Let me write it the way I have on my paper. Let me see if the g of x stuff works. So let's see, g of x equals the f of x function, and then I have plus 2. So just like I wrote it down. And then let's see what happens when I put the plus 2 in parentheses. So if I come over here and go inside my parentheses and put plus 2, I said that it goes 2 units to the left. All right, look what happens, 2 units to the left. So that's all this, that's the only thing that we're talking about in this particular section, is whether the graph moves left, right, up, and down. And when you do this in my math lab, you're going to have to start off with the parent function. And then you're going to have to move the graph. So let's look at an example. So if you were doing this in my math lab, they'll want you to start off with the parent function. So f of x squared. So whenever you're doing the parent function, f of x equals x squared, you can create a table. Always start, remember 0, the origin is always going to be a point. So put 0 in the middle and do -1 and 1. I think you only have to do 2 points. So -1 and 0, or 0 and 1 will work. So what happens if I do -1 squared? Well, -1 squared is 1. So that means that at the point -1, there's going to be a point at 1. So that's where that next point comes in. And at 0, 0 squared is 0. So there's your 0, 0. And at 1, 1 squared is 1. So the point 1, 1. So those 3 points make up your parent function. And then in my math lab, you need to tell the graph what to do to create your new function. So it says now graph g of x squared plus 1. Well, since there's a plus 1, that means that all these points are going to shift up 1 unit. So just 1 unit. So there's either going to be an arrow where you hit the up arrow for 1 unit and the graph will move up, or you actually have to type in which way the graph goes. But that's all you have to do. You have to just tell the original function what to do. So in this case, it moves up 1 unit. Here, the parent function is x squared. The x minus 2 is inside the parentheses. If you go to your chart, whenever there's a x and a minus number in the parentheses, that's going to be moved to the right. In this case, it's going to move to the right 2 units. So notice how the original parent function now shifted 2 units to the right. And then you have one that's a combination of both. They have a number inside the parentheses, x plus 4 squared, and a plus 1 at the end. You still have the original parent function. Because that's an x plus 4 inside, this would be 4 units left. And that plus 1 will be 1 unit up. So I highlighted my parent function, which is here. Shifted 4 units to the left. And then you go up 1 unit. So the last graph here would be your final graph. And I'm actually going to put that into Desmos. So x plus 4 squared plus 1. So this is f parentheses x, which is x squared. This is the parent function. And then I want to graph the translation, all right, a new graph of f of x plus 4 and then plus 1. All right, so that's x plus 4 plus 1 and move 4 units to the left and up 1. Or I could have just wrote it as parentheses x plus 4 squared. So this is the first way I did it was in function notation. And this way I'm doing it with just using the regular parent function. So it's the same. So could do y equals, or I think they have g of x. So g parentheses x. All right, so let me turn off the blue graph. So this is the f of x plus 4 plus 1. So that's all you have to tell my math lab is to move it up 4 units, move it to the left 4 units and up 1. Or, so you may see it in function notation, I'm going to turn off the red, or you may see it written in this form where they have the x plus 4 in parentheses and the plus 1 at the end. So that's all that you have to do for that particular section. That's translations of functions. We deal with translations. And then the next part, this is actually the 2.6 part. This is operations of functions. So this is algebraic stuff. So you have your function notations. You need to know how to read it both ways. F plus g in parentheses means you take the two functions and add them together. If you have a f minus g of x, sorry about that. So f plus g of x, you write it in that form. F minus g of x is f of x minus g of x. Same thing for multiplication, f of x times g of x, and then division. All right. One thing you need to know about division is that whatever's at the bottom, in this case g of x, that cannot equal 0. So they talked about that it's restricted for any x values such that, so even if you don't understand what this stuff means right here, it's restricted for any x values such that g of x equals 0. All right, we just state that so it's known. So we're going to find all 4 of these using the two functions that they give us. They give us f of x and g of x. So it says to find f plus g, all right, of x, which is the same thing as f of x plus g of x. Well, f of x is this 3x minus 2 plus g of x is x plus 7. So x plus 7. Anything, you don't have to put the parentheses, but I always, if I'm adding to something or subtracting, I always put a parentheses. When you add this together, you get 3x plus x, which is 4x, and negative 2 plus 7, which is plus 5. So that would be your answer. Let me move this out of the way for space. So let's go off to the side. So again, this would be 4x plus 5. All right, f minus g of x is the same thing as f of x minus g of x. So f of x, let me get some color coding going on here. Let me erase this stuff. So we'll say f of x, I'm going to put in this color, f of x. And then g of x, we'll use this pink or purplish. So when I get over here, f of x is what I have in this orange looking color. So this is 3x minus 2. Anytime you have a minus sign, you need to put parentheses or what's around what follows. So what follows is this g of x, and I'm going to put that in parentheses as x plus 7. So when you do that, you have to distribute this negative. So this becomes 3x minus 2 minus x minus 7. And when you simplify that, 3x minus x is 2x, and negative 2 minus 7 is negative 9. So that is your f minus g of x. And now we have some multiplication. F times g of x. So again, it's going to be this orange stuff, which is f of x times g of x. F of x is 3x minus 2, and g of x is x plus 7. So at this step, I will use FOIL, which most of you use, which is the distributive property. So what I have to do is I have to multiply everything in the second parentheses by 3x. And when I do that, 3x times x is 3x squared. 3x times 7 is plus 21x. Then I have to come back and multiply everything in the second parentheses by -2. -2 times x is -2x. And -2 times +7 is -14. Add like terms, I get 3x squared plus 19x minus 14. I can add those two together. And that's it. That's your final answer for the multiplication part. And then lastly, they have f over g of x, which is the same thing as taking the f of x and divided by g of x. F of x at the top is going to be 3x minus 2. And g of x will go at the bottom, which is x plus 7. And you leave it just like that. You can't factor this. It can't be simplified. So you will leave it as a fraction. Now at this point, because I don't have another example, this will be something I would suggest pausing the video and retrying this example. So this will be a good example to try. So go ahead and do that and see if you can get the same answers that I have here. All right. So also you may run into some examples where you may see something like f plus g of 2. So if you see something written like that, f plus g, and there's a number in front of it, all you have to do is go find the answer, the f plus g answer, which is here. So f plus g of x, all right, that's here. That answer to that was this 4x. Let me highlight this 4x plus 5. So what I'm going to do is I'm going to use the 4x plus 5, but in place of x, I'm going to replace x with 2. So 4 times 2 plus 5. So that's 8 plus 5, which is 13. And you'll see problems like that. They'll have both. In the same problem, they'll ask you to find f plus g of x, and then they'll come around and say find f plus g, and it will give you a number. And that's exactly what you would do. So if I saw something, if the question was f times g of 0, then I would find the f times g of x answer. So f times g of x, which is here. The answer to that is this stuff right here. So it's going to be this 3x squared plus 19x minus 14. And in place of x, I'm going to plug in 0. So 3 times 0 squared plus 19 times 0 minus 14. Anything that's multiplied by 0 drops off. So your final answer is just negative 14. So again, that's how you would go about doing problems that have a number in the parentheses. You would go do the operation first, and then you would substitute x in for whatever number they give you. All right. And now we have something called composition of functions. Let me see. Do I have? All right, composition of functions. So composition of function, that little f of g of x is how we say it. So let me write down this. We say f of g of x. Composition. This is not multiplication. This is composition, which is like a substitution. So we'll be doing some substitution. So it says find f of g and g of f. So first of all, let's find this f of g, and it should be an x beside it. So f of g of x. This is the same thing as taking the f function, and inside you should have g of x. So what you do is you start off with f of x. So start with f of x. So f of x equals what they give us, which is 3x minus 2. And then next you need to take x out. So take out x. All right, so we need to replace with parentheses. Replace with parentheses. So this would be f blank parentheses 3 blank parentheses minus 2. And inside the parentheses, you're going to put g of x. So inside of all these parentheses, you're going to put g of x. On this side, the left side, we just write g of x. But once we get across this equal sign, we have to write down what g of x equals. Well, g of x equals x plus 7. So in the parentheses over here, I put x plus 7. And then you only deal with the right side. So simplify right side. So if you like steps, this would be step 1, 2, and 3. When I simplify the right side, I get 3x plus 21. I have that minus 2 behind it. So then this becomes 3x plus 19. All right, next it says find g of f. So g of f is different from f of x. So g of f of x is the same thing as g written first, and then inside the parentheses you have f of x. So this stuff is inside. So this time, instead of we're starting with f of x, we're going to start with g of x. So I'm going to write down the g of x equation. G of x, which is given to you, is just x plus 7. So that's step 1. So start with g of x. Take out the x and replace with parentheses. So now in the next step, wherever I see x, I'm going to just leave a blank parentheses in place of it. So I'm done with step 2. And in the step 3, it says, oops, I forgot to do that. So take out the x, replace with parentheses, and then I meant to put in, I'm missing a step here. So that this would be step 3. All right, so here in step 3, we had to replace parentheses. So replace parentheses with g of x in this case. All right, and then you simplify the right side. So my next step would be to everywhere I see a parentheses, I want to replace what's inside the parentheses with f of x. So f of x goes here, and then on the right side, I put what f of x equals here. F of x equals 3x minus 2. So replace parentheses with g of x. That was a previous example because g of x was written inside the parentheses. In our case, we have f of x inside the parentheses. So that's what we're putting inside. And then the last step is to simplify the right side. So all I care about is the right side. So I drop these parentheses. 3x minus 2 plus 7 is 3x plus 5. All right, again, this will be a point where I will stop the video and try the examples that I have here, see if you get the same thing. All right, this would be good practice. All right, the last part you may run into, which you are, well, actually in homework you'll run into, in this same problem, they'll ask you to find something like f of g of 3. So just like before, you find the answer. So up here, this is f of g of x. So kind of coming in here. So we did all that work to find f of g of x. Well, they tell us here x is now going to be 3. Well, what's the answer to that? When we did all that work, the answer to that was 3x plus 19. So that answer is 3x plus 19. So in place of x, I'm going to plug in a 3. So 3 times 3 is 9. 9 plus 19 is 28. And then you'll see something like find g of f of 3. So again, you take the g of f of x answer, which is 3x plus 5. And in place of x, you're going to plug in a 3. So this is 9 plus 5, which equals 14. Alrighty. Alright, so this last example, I'm going to change this up because you won't see anything like this in homework. I want to do one that's similar to what you